Okay, hello guys. Now the next thing we are going to start is obviously we know what is atomic mass, what is molecular mass, so what is atom, what is molecule, everything we know. Now next part we are going to start is with what is unit. Unit, you know what is unit? What is unit? Now this is something which is used for measuring some physical properties. Physical properties means what? Physical properties means some properties of the substance which can be either observed or measured. Which can be either observed or measured. For example, suppose this pen is there. Now I can ask you what is the color of the pen. Fine, color of the pen is observed. So if it is observed, it's a physical property. What is the length of the pen? It can be measured. If it is measured, it's a physical property. Okay. What is the volume of the pen? It can be measured. Okay. So these are what is the physical properties. What is my height? Okay, fine. That's fine. That's observed, measured. What is my mind? You cannot observe it. You cannot measure it. So it is neither physical property nor any other property. So you cannot explain it. Physical property is some substances having some properties which can be either measured or observed. Now, whenever it is either measured or observed, they must be defined by certain units. Suppose if I ask you again the same thing I am asking you. If I ask you what is the length of it, what is the length of it, you will say, sir, 5 centimeter, 7 centimeters, 7 inches, 6 inches. But how do you know this? This inches, centimeter, whatever you are saying, millimeter. These are what? These are the unit of length, right? Okay. But what is unit then? Unit is not that is measured. 1 centimeter. How much is 1 centimeter? You don't know. If I say this much is 1 centimeter, you will accept that is as 1 centimeter, and accordingly you will measure the length of this. Yes. Now this is taken that 1 centimeter or any other unit is taken as standard, right? Okay. So unit is standardized. Okay. So like that, there are 7 different units. 7 different units by which we can measure the physical property, any physical property of any substances. Those 7 different units by which you can measure any physical properties are called the basic units. Okay. Now the IUPAC, obviously, all of you know what is IUPAC, International Union of Pure and Applied Chemistry. That's the international governing body of the study of chemistry. Okay. Who has told that there are 7 basic units, and those units are called the SI unit, what is standard international units. Okay, 7 basic units are there, standard international units are there, by which we can measure the physical property of any other, any substance, any other physical properties of any substance. So what are these 7 standard international units? The first one is length. So you must know this. First one is length, that is obviously meter. Then second one is what? Second one is time, that is second. Okay. Third one is what? Third one is mass, that is kg, that is kg. These 3, all of you know that these are the very basic units of it. Then obviously the next one is electric current. It is ampere. Electric current is ampere, which is also a standard, basic unit, and the standard international unit for electric current is what? Standard international unit for electric current is ampere. Next is absolute temperature. Let me just tell it only. Temperature, the international unit is Kelvin. There are so many units by which we can measure the temperature, but what is the SI unit? SI unit is Kelvin. Then is luminous intensity. Luminous intensity. This is not much required in our standard, but this is also a unit. In physics, little bit you need it, and that is what is that? That is candela. We write it by CD. we write it by Cd, candela. Okay, and lastly the amount. Amount is the unit. I will come to this. We have to know a detail of this. Okay, the amount, the unit is mole. Okay, so these are the 7 basic units which are called the standard, obviously the standard international unit by which we can measure the physical property of any substances. Fine. Okay, we'll see that. We will see the use of this. That is one concept you must know. As I told that we are studying still the basic concepts of chemistry. So first of all, we must understand that what are these, and then we are going to know slowly, or we are going to use it slowly. The next one more law, or rather 2 more laws we must know. The basic laws. The first one is out of that. The first one is Gay-Lussac's law of constant volume. Gay-Lussac's law of constant volume. First point about Gay-Lussac's law is that this is applicable only for the gaseous reaction. This is applicable only for the gaseous reaction. Now, what is gaseous reaction? Gaseous reaction means where the reactants, the chemical reaction, where the reactants and the products, all the reactants, all the products are in the gaseous state. They must be in the gaseous state. Then those reactions are called the gaseous reaction. That's the first point of Gay-Lussac's law. It is applicable only for the gaseous reactions. Fine. So let's just write one of such reaction. For example, suppose N2 plus 3H2. We have to write a balanced equation. 3H2 is producing 2NH3. You see it? Now N2 is what? That's a gas, obviously. We know that. How to represent this? This is represented by G. NH3 is also gaseous. This is ammonia is also gaseous. This is the balanced equation where we know that 1 molecule of nitrogen is reacting with 3 molecules of hydrogen is producing 2 molecules of ammonia. Okay, so this is a balanced equation, and this number of molecules that is in a balanced equation are called, you know what they are called? They are called stoichiometric coefficients. Stoichiometric coefficients. These values, that is, what are the stoichiometric coefficients over here? 1, 3 and 2. These are called stoichiometric coefficients. Okay. Now what Gay-Lussac's say, Gay-Lussac's law of constant volume says is that if the reaction is gaseous, then the ratio of this, if the reaction is gaseous, the ratio of the volumes of the reactants and products will bear a simple whole number ratio. In this particular case, the reaction is this, and the ratio of the volume of nitrogen, hydrogen and ammonia is bearing the ratio of 1:3:2, which is a simple whole number ratio. That is what is nothing but the Gay-Lussac's law of constant volume. Okay. Next law, one more law you have to know is that Avogadro's law. Okay. Avogadro's law. We are going to use this afterwards also, but at this moment only we have to know Avogadro's law. This is not very tough. Suppose some gas is there. This is also actually applicable for the gaseous, mainly gaseous reactions. But okay, it can be generalized to some extent also for the other states. Now what is Avogadro's law? Suppose some gas I had taken. Suppose I had taken here 500 gram of gas. Okay, 500 gram of carbon dioxide gas. And its volume is this much. Clear? At a condition, suppose the pressure and temperature are fixed. We are not going to change the pressure and temperature. Now, if I take 1000 gram of gas, 1000 gram of the same gas, so will the volume be same? Obviously not. The volume will be doubled, you know this. You can understand that at the same condition means when the pressure and temperature is remaining constant. That's simply the Avogadro's law. Now here I had written in terms of gram, but the amount, just now we had written the amount, so unit is mole. Okay, what is mole? We will come back to that. We will come to that obviously. But first of all, you must understand that this is no more gram now amount. We are going to tell it as mole. So what is this? That more the number of moles, more is the volume. Simple. Avogadro's law is what? More the number of moles, more is the volume, provided the pressure and the temperature are constant. And that is what is Avogadro's law. So we can write it like this. We can write it like this. At constant temperature and pressure, at constant temperature and pressure, the volume of a gas, is directly proportional to the number of moles, which is written by small a. Okay, volume of a gas is directly proportional to the number of moles. So these are rather the basic laws of the first part. The basic concepts of chemistry. First thing. Now I talked about so much of moles and moles. Now we are going to come into, hope you understood up to here. It's nothing very tough. Now we are going to enter into the little you can say tricky part, but I hope that you will understand that. That is called mole concept, and you have to understand it. You have to understand it, because without that you cannot move ahead. Okay, mole concept, understand it. The concept should be very, very clear. Okay, let me just explain it. Fine. Suppose okay, mole is what? Mole is the unit of amount. You know this. Okay, now what is amount? What is amount? What is amount? Fine. What is amount? Now suppose I had told you, go and get 500 gram of sugar. Fine. You will go, you have money, you will go to the shop, you will come and sir, this is 500 gram of sugar. After coming back, I asked you that how much sugar did you bring? You will answer, sir, 500 gram. Then I asked you the same question, another question I asked you, that how many sugar molecules did you bring? How many sugar molecules did you bring? Can you say? No, you cannot say, right? Okay, so this is a unit. This is also a unit of amount. How much is amount? This is also a unit of amount, gram. But by the unit of gram, what can you say? You can say only how much, right? Can you say 500 gram means how many? Absolutely not. Okay. So you know gram is a unit which tells us about how much but not how many. Okay. Now I tell another student that go and get 2 dozens of pen. 2 dozens of pen. 2 dozens. Dozens is the unit here. Dozens of pen. So he brought it, and after coming back I asked you that how many pens did you bring? How many pens did you bring? He is telling that sir, 24 pens I am bringing. 24 pens. 2 dozens. 2 dozens. 24 pens I am bringing. Then I asked him, how much pen did you bring? Please understand it very minutely. How much pen did you bring? Can you say? No. Until and unless some other data is given to him, he cannot say. Here also the same thing. Until and unless the other data is given to him, he cannot say. Right? Okay. So dozen, only dozen, which is a unit also of amount, can tell us only what? Can tell us only about how many, but not about how much. So there are certain units. There are certain units of amounts which can tell us only about how many. There are certain other units also which can tell us only about how much. But none of them can tell us both. Okay? But the unit of mole, the mole can tell us both. It can tell us both how much and how many. If you understand what is mole, it can tell us both how much and how many. How? Let us see. Okay, let us see with that sugar only. Fine, let us see with that sugar only. Fine. Okay, suppose we are talking of sugar, but for that we must know what is the molecular formula of sugar. So the molecular formula of sugar is C12H22O11. That's the molecular formula of sugar. Okay. So let's find out the molecular mass. Okay, then it will be easy for you. So what is the molecular mass of its carbon is 12. So 12 into 12, right? Plus hydrogen is 1 into 22. Plus oxygen is 16, so 16 into 11. So that is equal to 144 plus 22 plus this is how much? 11 6 just 66, 11 1 1, 176, right? So that is equal to how much you see? 6 and 2 8, 8 and 4 that is a 2, 7 and 1 8, 8 to 10 and 4, 10 and 4, right? 10 and 4, 14, 14, this is 14, 1, 2 and 3, 342. 342 is the molecular mass. Okay, 342 is the molecular mass. Okay, I think I had done it correctly. 144 plus 22 plus this is 176. Okay, so 6 and 2 8, 8 and 4 12, 12 to 1, 7 and 1 8, 8 and 2 10, 10 and 4 14, and then 342. Fine. Now I told you that go and get 684 gram of sugar. 684 gram of sugar. So you went, nowadays the digital weighing machines are there, so you got 684 gram of sugar. After coming back, I asked you that how much sugar did you bring? You will say, sir, 684 gram. Fine, your answer is perfect. Next, I asked that how many sugar you had brought. For that, now you must know the mole concept. Okay? Fine. Let us know what is mole concept. 1 mole. 1 dozen. First, we are going to know how many. How many? Okay? 1 dozen. 1 pair. Okay? Tell me, 1 dozen means how many? Yes, very good. 12. 1 pair means how many? Yes, very good. 2. Same way, 1 mole of anything means 6.022 into 10 to the power 23 of that thing. And this particular number is called, you know what? This particular number is called Avogadro's number, and it is denoted by Na. N is number, A is Avogadro. Okay, Na. Okay, fine. So Na is equal to how much? So you understood now. 1 mole of any substance means how many of that substance? Yes. So 1 mole of any substance means 6.022 into 10 to the power 23 of that substance. Right? There is no issues over here. Fine. Now how much? How much? How many you understood? 1 mole of anything means how many of that? You understood that. So if I ask 5 moles, how many you can understand that? Just 5 into this. 5 dozen means 5 into 12. 5 pairs means 5 into 2. Just like that. Okay. 10 mole means 10 into this. Okay. Whatever. Okay. So now how much? To know how much, we must know what substance we are talking of. We can talk the atom. We can talk about the atom. We can talk about the molecule. Or we can talk about the ion. Fine. It can be cation or an ion, whatever. If it is atom, it should be atomic mass. Atomic mass. If it is molecule, it should be molecular mass. And if it is ion, it should be ionic mass. Generally, ionic mass and atomic mass are same only. And that should be expressed in gram. The atom whose atomic mass should be expressed in gram, molecular mass expressed in gram, ionic mass expressed in gram. For example, suppose if I talk about water. Okay, what is the molecular mass of water? So 2 into 1 plus 16, that is equal to 18U, right? 18U, but 18U is not 1 mole. What is 1 mole of water? 1 mole of water is equal to, as I told, its molecular mass. Molecular mass is 18 expressed in gram. So 18 gram of water is 1 mole of water. Did you get it? What is 2 moles of sodium chloride? What is the molecular mass of sodium chloride? Let us find it out. So 23 is sodium plus 35.5, that is equal to 58.5 U. That is the molecular mass. So molar mass means how much? 1 mole means how much? 1 mole means 58.5 gram. Yes? So 2 moles means how much? 2 into 58.5 gram. Fine. So you can very easily get the number. I mean, how much is there? But provided you must know what? You must know the molecular formula. So now, 1 mole of sugar means how much? 1 mole of sugar equal to how much? Tell me. Because already we got the molecular mass. Okay, that much use. So what is the sugar? 1 mole of sugar? 342 gram. So 342 gram means 1 mole of sugar. Now I told you to bring 684 gram, right? So how much mole did you bring? So 342 means 1 mole. So 684 means just 2 mole of sugar you brought. Now 2 mole of sugar you brought, and I am asking now how many sugar you brought. How many sugar you brought? 2 moles means how many? 2 moles means 2 into 6.022 into 10 to the power 23. So now see, you can give the answer very clearly. Okay, I told you to bring 684 gram of sugar, 684 gram of sugar, and then after coming back I asked you that how much sugar you brought. How much sugar you brought? You told how much? You told, sir, 684 gram. Now I asked you how many sugar molecules did you bring? How many sugar molecules did you bring? Obviously you know that you brought 2 moles of sugar molecule that you had calculated. You know the mole concept. So how many sugar molecules did you bring? 2 into 6.022 into 10 to the power 23. So that is equal to, you can write 12 into 044, right, into 10 to the power 23. This many sugar molecules did you bring? So is the mole telling us about how much as well as how many? That's the mole concept. It's the most important concept of chemistry, and you must understand that we can coordinate between how much and how many. So mole is the unit of what? Mole is the unit of amount, and whenever we are talking of amount means what? Whenever we are talking of amount, we must know that it can tell us about how much also, how many also, right? Okay, so obviously the concept will be much more clear when we are going to do some numericals. Okay, so the numericals we can do is suppose the question, calculate the number of moles in 7.85 gram of iron. Calculate the number of moles in 7.85 gram of iron. Just 1 or 2 questions we are going to do, then more you have to practice. Okay, obviously mole concept has to be cleared. Okay, calculate the number of moles. Calculate the number of moles of 7.85 gram of iron given, obviously there has to be given atomic mass of iron equal to 56 U. Okay, atomic mass of iron equal to 56 U. So what does this atomic mass says? That its atomic mass is 56 U. When it is expressed in gram, that is 56 gram of iron means 1 mole of iron. Yes, that's the concept. So 56 gram of iron equal to 1 mole of iron. 1 mole of iron. That's the mole concept. Clear? So 7.85 gram of iron. So 7.85 gram of iron equal to how much mole of iron? We can very easily find out. 7.85 divided by 56. This much mole of iron. Now if somebody asks you that how many atoms are there, so this many moles is there means how many atoms are there? 1 mole contains 6.022 into 10 to the power 23. So this many mole, whatever mole contains into 6.022 into 10 to the power 23. Simple concept, but you must understand it. You must solve a lot of numericals. Okay, chalo, one more we are going to do. How many atoms of oxygen are present in 300 gram of calcium carbonate? How many atoms of oxygen? How many atoms of oxygen are present in 300 gram of calcium carbonate? How many atoms of oxygen? How many atoms of oxygen? How many atoms of oxygen are present in 300 gram of calcium carbonate? Given atomic mass of calcium equal to 40, carbon equal to 12 and oxygen equal to 60. Okay, fine. So see, it's very simple again. Calcium carbonate, the formula you should see. See, in one molecule of calcium carbonate, how many atoms of oxygen are there? Can you say it from the formula? In one molecule of calcium carbonate, how many oxygen atoms are there? 3 oxygen atoms are there. We'll write it aside. We will write it aside. Okay? Because we have to find out the oxygen atoms, right? We have to find out the oxygen atoms. So we are going to write it aside that in one molecule of CaCO3, okay, the number of oxygen atom equal to 3. Fine? That's just clear from the formula only. Okay? Now, 300 gram of calcium carbonate is there. First of all, we must understand that 300 gram of calcium carbonate means how many molecules of calcium carbonate? How many molecules of calcium carbonate? And to know that, first of all, we must understand how much mole is there. And to know the mole, we must know what is its molecular mass. So we must calculate its molecular mass. So what is the molecular mass of calcium carbonate? Let us find it. Calcium is 40 plus carbon is 12 plus this is 3 into 16, that is equal to how much? 40 plus 12 plus 48, that is equal to 100. You see, that's equal to 100. Okay, so 100 gram of calcium carbonate equal to 1 mole of calcium carbonate. Yes, that's the molar mass. Okay, therefore 300 gram of calcium carbonate equal to how much? Obviously it will be 3 mole of calcium carbonate. 300 gram of calcium carbonate means 3 mole of calcium carbonate. So you have 3 moles of calcium carbonate molecules. 3 moles of calcium carbonate molecules means how many calcium carbonate molecules? 3 into 6.022 into 10 to the power 23 molecules of calcium carbonate are there. Now each molecule, in one molecule there are 3 atoms of oxygen. So in 3 into 6.022 into 10 to the power 23 molecules of calcium carbonate, okay, that much molecule is there in 300 gram. We had calculated this. How much atoms, number of oxygen atom is how much? Number of oxygen atoms equal to how much? 3 into 6.022 into 10 to the power 23. That is equal to how much? 9 into 6.022 into 10 to the power 23, and you can very easily calculate that, and you can say that sir, this many molecules are there. So hope the mole concept is clear, the concept is clear. Now as I told, it will be more clear. Concept is very small. It will be more clear if you solve the numericals. So please and please and please solve the numericals, solve a lot of numericals. If any queries there, please let me know. I will solve it out for you. Okay, I will make you understand again. But you must go ahead with a lot of mole concept solution. Okay. So what we studied today, I'm just finally recapping it, and we are going to end it for today. So what did we study? The first thing we studied is that what is what did we study first? What is the SI unit? Okay, SI unit. So SI unit is what? That is physical parameters which can be measured or observed. Okay, are expressed by certain units, but all the units are not going to be accepted or not accepted by IUPAC. Certain units were accepted by IUPAC. Okay, and obviously there are 7 fundamental units. We should say them fundamental units by which you can measure any physical parameter of any substance. Okay, and those 7 fundamental units are called the basic units of basic physical units by the SI, or simply the SI units. What are these? Mass, length, time. These 3 are there. Obviously, luminous intensity, temperature, then what? Amount and the current. Okay, amount and the current. Okay, and what are the units? You must know it. Next, what did we study? We studied the Gay-Lussac's law that is applicable for the gaseous reaction. Gaseous reaction means what? The reactants and the products both are gaseous. Okay, and what does it say? That the volume of the stoichiometric coefficients of the reaction is always bearing a simple whole number ratio. We have seen that. Next one is Avogadro's law, which is again mainly applicable for gases. So what does it say? That if you increase the volume keeping the other parameters constant, the number of moles will also increase, or number of moles increase, the volume will also increase. That is Avogadro's law. Okay. After Avogadro's law, what did we study? We studied the mole concept. What is mole concept? Again, in brief, I am saying any unit amount. It's the unit of amount first of all. Okay. What is the amount? How many? How much? Any unit of amount can either define how many or define how much. None of them can define both excepting the mole. Okay, so mole can define both how many and how much. How many? 1 mole means how many? 1 mole of any substance means 6.022 into 10 to the power 23 of that substance. Okay, and that particular number is called Avogadro's number, and we denote it by Na. Okay, and 1 mole of any substance means how much of that substance. That depends on what substance we are talking of. If it is atom, its atomic mass expressed in gram. If it is molecule, its molecular mass expressed in gram. If it is ion, its ionic mass expressed in gram. That much gram of that particular substance is called 1 mole of the substance. Hope it is clear, and we can correlate them, how many and how much, from the mole concept only. So till here for today, please solve the numericals. Please and please solve the numericals. Okay, as you solve the numericals only, we are going to go further. Okay, then we are going to move further. For today this much. See you. Take care, stay safe, stay healthy.